Hey, welcome back. We're going to take a look at Olympiad 1, problem number 4. The problem reads, 2 pencils and 3 pens is 78 cents, but 3 pencils and 2 pens cost 72 cents. How much does 1 pencil cost? So you're probably looking at this thinking that it's an algebra problem, and in fact it is. But that's not the only way to solve it. So if you know algebra and you can solve it that way, I'm just going to let you go ahead and do that because it's fun and you'll have a blast. But I'm focusing this video for the kids who don't know algebra yet, and there's still a good way to solve it. In fact, for some of you who know algebra, you might even prefer this technique. So let's take a look. I'm going to start by writing 2 equations for our sentences here. Now, pencils and pens both begin with P, so I can't use P for both of them. I'll just get confused. So I'm going to use L for pencil. I always like the letter L, and whatever letter you like, you can use. Plus 3, and I'm going to use N for pen, is 78. And I'm going to write over here 3L plus 2N is 72. And now I'm going to do kind of a little Sherlock Holmes on these and ask myself, well, what else can I tell? And it looks to me like the pens and pencils are not equal, because when I've got 5 items up here, it's 78 cents. When I've got 5 items up here, it's 72 cents. So that tells me that the L does not equal the N, or the pencils are not equal to the pens. Likewise, if I have 1 more pencil and 1 less pen, my price goes down. So I'm going to guess that my pens are greater than my pencils. That's something else I can guess. And then finally, looking over here, the last digits are 8 and 2. And that tells me a lot of information about what could work for this. In fact, I don't have to try every number. I just have to try things that will add together and end in an 8 and 2. And there just aren't that many of them. Finally, I'm going to take another look at, well, if they were priced the same, and I know they're not, but if they were, what would they cost to give me a starting place? So I'm going to do a little division here. 5 into 78, 5 goes into 7 once, gives me my 5, bring down my 2. 5 goes into 28, 5 times 25, 3, bring down my 0. 6. So my starting place is going to be around 15.6. So because I'm doing this for a video, I'm just going to erase some of this to make some room. So I've got some information here that's going to help me solve this problem. And I'm also looking at, I've got groups of 2 groups of things, and 3 groups of things, and it doesn't matter which is which. I'm actually just going to look for groups of 2s and groups of 3s. So I'm going to make a list of powers of 2. So let's say I'll start it at 8, and we'll go 2 times 8 is 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So that's a lot of 2s, and my answer's probably in here somewhere. I just have to figure out where it is. And I'm going to look at groups of 3s, and I'll do the same thing. I'll start at 15. So 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. And my 3 of something is probably in here somewhere, and I can put a little list up here, my 2s and my 3s. So I know it's my starting place is going to be around 15. So 2 of 15 would be 30. So I'm going to start with that. I'm going to start with 15, and let's see if anything would work with 15. 30 and what? 30 and 48. Is 48 on my list? It is. 30 and 48 are on my list. This is looking pretty promising. 2 times 15 plus 3 times 16, and this is giving me my kind of average. It's not exactly 15.6, but it's close. So that would be 30 plus 48 equals 78. Woohoo! I'm done! But not quite, because it's got to work for both equations. Now this is where a lot of kids are going to stop. They're going to stop and say, oh, I'm done, but let's see if it works for both. 3 times 15 and 2 times 16 would be 45 plus 32, which is 77. That doesn't work, because it doesn't work for this equation as well. So I know that 15 and 16 don't work with each other. So I'm going to erase that to make a little room. and I know that I can get rid of those two. So in this case, the number is a little big. So what I'm going to do is I'm going to cross this out. I'm going to go this way and try 28. So 28 plus 50, is 50 on our list? It is not, so I can get rid of that. And I'll just erase my 28, and I'm just using process of elimination here. Let's take a look at 26. 26 plus what would be 78? Let's, it's not that, doesn't take that long. Let's just do a little subtraction. 52. Is 52 on our list? It's not, so it can't be 26 because it would have to be added with a 3 of something. So let's take a look at 24 and see if 24 will work. 24 plus what is 78? Well, if we needed to, we could do a little subtraction again, no big deal. 54. 54 is on our list, so that would be 2 times 12 plus 3 times, let's say you don't know what 3 goes into 54, this won't take long. 3 times 18 equals 78, and that's true. 2 times 12 plus 3 times 18 is 78, so that works. Well, let's take a look at 3 times 12 plus 2 times 18. 3 times 12 is 36. 2 times 18 is 36. That checks. Our answer is the pencils are 12 cents each. The pens are 18. So a pencil is 12. And that's our answer. Awesome job. I hope you could see how we used a little bit of trial and error to make this a little bit simpler.